SimCenter Femap 2022.1 includes support for Solution 402's flexible slider joint capability. Flexible slider joints are similar to slider joints, except the track can be both flexible and curvilinear. For flexible sliders, the track is defined by beam elements. In this model, I'm going to define a flexible slider joint to drive this car body along a predefined track of beam elements. This is similar to the type of setup you'd see in an automotive manufacturing facility with the production lines. In Femap, flexible slider joints are a new type of simulation entity which can be defined from the model info tree or from the main menu. Creating a new flexible slider joint takes us to the Nastran flexible slider dialog, where you can define the parameters for your flexible slider joint. The first option is the flexible slider type, which there are 4 that can be defined: spherical, cylindrical, prismatic, and universal. Here, we're going to define a prismatic flexible slider joint. You can see that we also have other options for defining things like a driver load on the flexible slider joint, which there are multiple types, such as force, displacement, and sensor, and different types of friction options as well. For now, we're going to leave these alone. In the Displacement Entities group box, I'm going to select the node that I want to displace along the track of beam elements. I can do this by defining a node group which contains the nodes that I want to slide along the flexible slider joint, or creating a dynamic selection list of the nodes. Here, I'm going to specify the dependent node of this RB. For the slider trajectory, I'm going to define the beam elements that comprise the flexible and curvilinear track. Again, I'm going to create a dynamic selection list to define the beam elements. Select one here and specify that I want to add all connected elements. In my Solution 402 analysis set, under the Options branch, I'm going to select the flexible slider that I'd like to export to my analysis. All right, let's analyze the model. So the analysis ran successfully, and I'm now going to animate the analysis study to post-process the evolution of the deformation and stresses in both the flexible track and the car body. Note the deformation of the track of beam elements as the car body slides along the track. And that's all.